All right, good morning. Everyone enjoying the conference so far? All right. So today I'm going to spend some time just talking about some practices and methods of software development that I have particularly found helpful in building modern, scalable applications, both back-end and front-end, over the course of my career. And who am I? I am a Senior Director of Engineering for the Convey platform. I've been working on the Convey platform for about 6 years, 6+ years. And I've worked on many aspects, both as an engineer, writing some of the key components of the Convey platform, as well as leading teams to work on the Convey platform. And I've worked on a wide variety of different parts of the platform, pretty much everything except front end. I've done the work on the Flex component, which is the component of the Convey platform that runs and executes code, customer code. And I've worked on some of the authentication stuff. I've worked on some of the client SDKs. So pretty much anything except the front end web console has kind of my stamp on it a little bit. So we're going to talk about today, first, why the need for modern app architectures at all. Why do we have to change our thinking in this new era of digital app experiences that customers are expecting? And then we'll start to look at some of the tools that are out there that you can avail yourselves of to help make that move to modern architecture, to digital. We'll follow that up with a little bit on some practices. We'll talk a lot, just briefly on some of the buzzwordy things like agile and lean and what those really mean and how you should try to approach those within your organization. And then we'll look at platforms. What does it mean to, what does the cloud mean to modern applications? What does serverless mean? Some of the kind of more contemporary app platforms, how do they help you as a developer to deliver modern experiences? And finally, we'll just take a very brief look at the end of how Progress Convey utilizes all of these things to deliver an application platform to help you build your modern apps. So first, why the need for modern platforms to begin with? Well, we live in an age where technology is rapidly accelerating. And companies are using technology to disrupt traditional business processes, traditional models, traditional industries. Everything from Amazon to WeWork to Uber and Lyft. Companies are taking those new technologies that are rapidly evolving and translating them into new business models. And that pace is accelerating. We started off with the web in the mid-90s, and then it took 10 years before we got to mobile. Since then, we've had conversational UX with chatbots and with home digital audio assistants like Google Home and Amazon Alexa. We have AR and VR that are just emerging. We have machine learning and artificial intelligence. And all of these things the rapid pace of innovation is accelerating and is causing, and companies that are taking advantage of it are changing the business models associated with their industries. And so we're in an age of digital disruption. Markets are segmenting into two classes of companies: disruptors and disrupted. And apps, these modern apps, are the means for the disruptors to reach customers, improve business processes, cut costs, and most importantly, deliver better value to their customers. Customers are expecting modern digital experiences. And companies that deliver on those experiences are the companies that are becoming the winners. Modern app architectures, one of the key challenges of a modern app architecture is that customers expect the type of experience they want, where they want it. So you not only have to build a website, you have to build a website, you have to build an iOS app, you have to build an Android app, you have to build a conversational app for customers to reach out to you on Facebook Messenger or Slack, or to respond to an Alexa skill to respond to a query. Modern apps require rapid iteration. The pace of change is accelerating. Gone are the days when you could release a piece of software once a year or once a quarter. Now, customers are expecting rapid improvement, rapid iteration, once a month, once a week, sometimes even once a day. Elastic scalability. Consumers are expecting the apps to be functioning and working at all times. And you have it's very difficult to plan for those events when you might need scalability at any moment's notice. Take a marketing campaign that has unexpected high results, and all of a sudden, 20,000 people are trying to reach or download your app at the same time. And modern apps have to be conducive to change. Because of the rapid pace of innovation, and because companies everywhere are trying new things, apps need to be built in such a way, in such a modular way, that they can be easily modified and adapt to changing circumstances. But building these modern digital apps is hard. Oftentimes, organizations lack resources and processes that are necessary to deliver these apps at scale. And you can't just throw out the old and just start fresh new. You have existing infrastructure, existing data that you need to leverage and deliver that to the users of your app. And you can't just, for example, throw out your ERP system because it's old and slow. You need to somehow leverage that data but still deliver a feature-rich, very fast, mobile-scale experience to your customers. And current architectures can't meet today's speed and flexibility requirements. Implementing a modern cloud architecture is hard. It's easy to get started. Anyone can go up and go up to Amazon, go up to AWS, provision an EC2 instance, and get going. But it takes a lot of knowledge and a lot of research and a lot of effort to make sure that that scales correctly, to make sure that it's secure, to make sure that it's performant. A modern application architecture is needed to allow for the speed and agility required for this digital transformation. So now we'll look at some of the tools of the trade. What are some of the tools and the choices that you can make use of to help to deliver these types of modern apps? The first thing is you need the right language. There are more software programming languages out there than I can count. And trying to determine which language to build your next modern app in is a very important decision for a lot of reasons. The first is it needs to be the right tool for the job. Now, I'm not going to come here and say this one language is the one be-all, end-all language that you should be developing in. But there are certain languages that are better for certain tasks than others. If you're looking to build an app that relies heavily on machine learning, for example, you'll probably pick R or Python. If you're looking for a language to deliver a highly scalable web service, you're probably looking at Node.js and JavaScript. You also want to consider a language that has wide adoption and developer affinity. You don't want to pick a language that is a niche, that maybe there's a vibrant community behind it, but it's very small. Because that will make it very hard for you to attract talent and to get the engineers you need to be able to build your apps. And you want a language that developers love, because that's key to retaining talent. If it's a language developers can't stand working with, you won't retain that talent for very long. A friend of mine once worked at a company that had its own proprietary software language. And he lasted there about 3 years. And that was the general pattern. People would go, they would learn language. Usually, that company ended up getting engineers right out of college. They'd stay there for 3 years and they'd leave because nobody really liked working on the language. So you need to have something that interests developers and is something that they want to continue doing. So besides the right programming language, I would highly encourage people to seriously look at making as much use of open source as you can. Don't reinvent the wheel. There's a lot of tasks that are common across many, many different types of applications. For anyone who has used Node.js before, Express is a common web framework for delivering web APIs. Now, you could go in and spend hours, days, weeks writing your own web framework, but why? Why would you want to take that time and focus on a problem that somebody has already solved, rather than focusing on your own value, the value that you add to your application? Working with open source also allows you to take advantage of the community. There's a lot of expertise out there, and by taking advantage of a large community, you get the advantage of being able to rely on expertise outside your own, so you don't have to become a master of every aspect of software development. So utilizing open source for these common problems allows you to focus on what adds value for you. What adds value for your app? Why is your app unique and different, and how does it help your business? Not on repeatable solve problems. And if you do utilize open source, I encourage you to give back to the community. The community only thrives because people participate in it. So even something as simple as submitting issues when you find a bug, or assisting others by answering questions on Stack Overflow. And at its peak, if you find something or a new feature, submit code. The continual giving back to the community is what helps open source thrive and gives value to all of us as we continue to utilize it for our own software projects. The next thing I'm going to talk about is productivity enhancers. And sometimes these can be a little bit controversial to some people, but I tend to look at it as, if you think of a good example, there are very few software engineers today that do not make use of an IDE for their development. There's still some who will stubbornly stick to Notepad or Vim, but for the most part, everybody who develops software is using an IDE. And that helps them speed up their development. It helps them debug their software code and produce higher quality results. And so there are other productivity enhancers that help you move faster and get done repeatable, common, difficult tasks that otherwise would add to your development time and make your product take longer to come to market. The first is UX builders. Now, it's certainly possible to go in and write code to develop a good UI. But let's say you do that, and you place a button up on the corner of the screen. And your product manager or you decide that it doesn't look quite good up there, so I need to move it down a bit. Well, if I'm working just in code, I have to go in, edit some XML or edit some code file, and change the number of pixels relative to whatever position, and it moves the button down, and then I have to go back and view it. And repeating that over and over and over again can get tedious and can take a long amount of time, and it can be very impractical for these rapid development cycles that are needed. So UX builders provide tools and easy ways for you to be able to work in the case of a web and mobile, to work in a kind of a WYSIWYG environment, drag and drop and move things to match what the vision is for your app. And so to remove that overhead. data integration tools. So, and then the next one is data integration tools. Now, as I mentioned before, you often have existing data that you need to bring down into your new modern apps. And these data integration tools, such as Convey's Rapid or Progress's Data Direct hybrid data pipeline, allow you to quickly and easily bring data in from any data source in a fairly easy way and make it available to modern front-end applications. Then SDKs. These are less graphical, but still extremely useful. A good SDK will take, or library, will take common tasks that, if you had to write yourself, may take hundreds of lines of code and solves that problem for you, giving you something that you can utilize by writing one or a few lines of code. So a software development kit or a library does the job for you, but still gives you the control that you need to do what you need to do for your app. Next thing is cross-platform frameworks. As we mentioned earlier, one of the challenges of modern apps is that you have all of these different platforms, and they all have different programming languages and different frameworks. You have iOS, which uses Objective-C or Swift. You have Android, which uses Java or Kotlin. You have Chat, which uses a variety of different API formats, and many other different types of frameworks. So cross-platform frameworks allow you to focus on one common language or framework to write code for all of the different channels that you want to make use of. Gives you better utilization of your development resources, allows your developers to focus on one specific way of doing things. And then you only have to, you can write once, deploy to many platforms, and then you only have to focus a little bit on the uniqueness of each platform. For example, if you want to tweak your Android UX a little bit to match how users expect to see things in Android versus iOS, you can do that while sharing the bulk of your code among the two different platforms. Now that we've looked at some of the tools, we're going to look at some development practices and building for agility. So the first thing, when you're looking at how you develop your software, you want to make sure you keep in mind an agile mindset. Now, agile is a word that is thrown out everywhere as the way to write software, and different people that have it mean different things. But here I'm not talking about agile as a software methodology, but just staying agile and being adaptable. And some of the core principles of that are to build fast, iterate fast, get continuous feedback from what you build, from your users, from your sales team. Incorporate that feedback into various iterations, and build more with less. Now, there are generally three categories. When software teams adopt Agile, there are generally three patterns that I've seen emerge. The first pattern is companies that have long had, very involved software development practices involving specification documents and document after document, and just very, very high waterfall concept development practices, realize they need to do Agile, and so start to bolt that onto their existing process. When you do that, you end up something like this, which at the end of the day helps a little bit, but misses the big picture. The second pattern is teams that will take a specific Agile methodology, whether it be Scrum or Kanban or extreme programming, and bolt it into their process, and or replace their process completely with that, and then follow it religiously, even if it doesn't always make sense. And the third team is the one that looks at what other teams have done and tries to incorporate them to fit how best their teams work and communicate with one another. And I think that is one of the key things to think about with Agile, is that Agile is not Scrum. Scrum is a great methodology, but it's one methodology. It's not the only methodology. Agile is a set of principles, not any one methodology. I encourage all of you, if you haven't done it in a while or if you've never done it, to go and Google the Agile Manifesto and look at each one of the principles that are outlined there and see how your organization is utilizing those principles and see where you need to improve. Improvement is not something that ever goes away. No one methodology is appropriate for every team or organization. Find one that fits the closest, and then this is the important thing, iterate on that methodology. Even if you take Scrum or extreme programming and say, we're going to start this today and we're going to just follow it to the letter. After you use it for a while, do a retrospective. See what works for you, what doesn't work for your team, and then change it. Don't feel you have to be beholden to the ideology, to the methodology. Realize that the principles of Agile are about communication, are about delivering software faster, not about how many, whether or not I put sticky notes up on a storyboard. And I'm not dissing that. Those are all good things. Focus on the tenets of Agile. Don't be beholden to any one methodology. Stay lean. Now, lean is another of the buzzwords. And there's a lot written on it, and there's a lot that goes into lean. But the one thing that I want to just call out from lean that I feel is critical in developing modern applications is seek feedback early and often. From customers, from focus groups, from prospects, from your sales team. And continually adjust your plan based on that feedback. I've been part of software projects where we came up with a plan, developed it, worked 3 months, and then after the 3-month part, we decided to start getting some feedback. And it turned out we were way off base. But at that point, it was too late, and it was deemed too late to change course because we had already put that much effort into it. But at the end of the day, the worst thing you want to have happen is you deliver a feature after 3-6 months of work to find out that it isn't quite what the customer needed, or it doesn't quite match up and it needs some adjusting, or worse yet, nobody decides to use it. So you want to continually get that feedback, whether it be from, say, even internal feedback from your internal teams, internal stakeholders, going out to prospects, doing focus groups, going to current customers, and then continually iterate your plan and make adjustments to try to build the best product possible. And then the most important thing is to measure those results. As you adjust your plan, look at how usage patterns change among your users. See whether the feature is getting more adoption or less. And utilize the MVP effectively. That's another term that has a lot of overhead to it and a lot of different opinions on what it means. But I think focusing on the two words, minimum and viable, they go together. You want to build the smallest unit of work possible that allows you to get that feedback and measure results, but is viable, something that can be tested and will be accepted by users. A lot of times you have teams focus on the minimal part, and they put out something that is kind of useless to use to try to get some feedback, and that feedback ends up being not very useful. So keep in mind both of those. It has to be, you want to keep it small so you can get that feedback and try to deliver that value, but you want to make sure it's something that's viable for your customers to use. Embrace continuous. Now we have continuous delivery falls into a lot of categories. And the first, or has a lot of subdivisions. The first one is continuous integration. Now, the idea of continuous integration is that you continually are integrating any code that you write into the mainline branch of your source repository. And the theory is that that mainline branch should be deployable at any point in time. Doesn't mean you're going to deploy it, every time you merge something in, but that theoretically it is of high enough quality that you could deploy it if you needed to. So continuous integration means you merge to your master branch, mainline branch frequently. You don't have long-lived branches or, if you're using GitHub, pull requests, and you make a heavy use of automated testing. Now, one of the kind of anti-patterns that I've experienced and learned from is the idea of having a breaking off from your master branch, doing a feature branch that may take 2 to 3 months to get done, and then attempting to get that into the mainline branch. And by that time, the mainline branch ends up having had change, or that mainline branch has changed, and you end up with conflicts, you end up with bugs that pop up. And so the thing to keep in mind is the longer that you're developing off of that mainline branch, the harder it is and the more risk there is to merging it back in. So one of the lessons learned for me has been to try to keep those things small. And at minimum, don't have code live outside of your mainline branch for more than a week or 2 at most. If you can do it more often, do so. Continuous deployment. Now, the continuous deployment in its strictest sense means that as soon as you merge something into your master branch, it gets deployed immediately to production, or it gets released to your customers. Now, that isn't always practical, but I think the takeaway from this isn't that you necessarily follow that strict continuous deployment practice, although it's a good one if you can do it, but to deploy on a regular basis. At Convey, we deploy changes to our service multiple times a week. I think I did an analysis about a month ago where we were doing about 40 different releases to our production services a month. Our SDK team, led by Vinay back there, deploys new versions of the SDK typically at minimum once every sprint, which is once every 2 weeks. Is that right? Yep. And so now, when you deploy code that frequently and that early, it doesn't mean that everything is available. Not everything is generally available to your customers when you deploy it. Sometimes it is, depending on how small the feature unit is. But utilizing tools such as feature flags, A/B testing, early adopter and beta programs allows you to get the code in the code base out to production, out to maybe a subset of users who you can use to do some verification and validation on the feature without making it generally available. You see this pattern a lot in a lot of modern deployed products. For example, Google Chrome. If you search some of the news sites, you'll often find news stories about looking at the Google Chrome code base. It looks like this feature might be coming. And it's because, well, Google Chrome is open source, so anyone can look at it. But it is because the Google Chrome team is partially deploying features that aren't necessarily available to the general public early and often. And so that has a lot of advantages of making sure, giving your code time to bake and time to make sure that it's stable, and giving some early adapter testers the ability to test it in real-world scenarios. And why do we do this? Why do we do continuous integration, continuous deployment? To provide continuous value to our customers. A partial feature that delivers value is better than waiting until a whole feature vision is complete. A lot of times, and this happens at Convey all the time, we'll get in a room and we'll come up with this grand vision of this awesome feature that we want to deliver to our customers. And looking at the feature, we realize it's going to take us 6 months to get everything done. And what we do then is we try to break it down. We try to break it down into small units and look at, is there a subset of users that could use a part of this feature today and derive value from it? And so that's why, if you can deliver that value, first of all, you deliver value to the customer. You deliver value to your sales team because now they have something else that they can go and sell. And by doing that earlier and in smaller chunks, you give that impression of a continual delivery stream and that your platform is constantly or your product is constantly evolving. But it also has the effect of de-risking the entire feature set. Because the bigger a change is, the bigger a new feature is that gets rolled out, the more risk there is for problems and errors. The human mind is able to focus only on a certain amount of surface area at any one time. And if you can focus on just a small surface area at once, you're very much more likely to find bugs and issues before they become problems for your customers. So next we're going to talk just a little bit about platforms. So everybody has heard about the cloud. Why use the cloud? Well, it provides many benefits, but I'm going to just highlight a few here. It allows you to provision only what you need, but provides elastic scale based on utilization. So, in the traditional on-prem hardware model, you have to not only plan out for your average workload, but your peak workload. And sometimes you have to spend a ton of money on infrastructure that you only need 5% of the time. With the cloud, you can just provision what you need and trust that you can scale based on utilization. Protection from unanticipated spikes, removes uncertainty from capacity planning. There was a situation recently where one of our teams had a customer come in with a much higher than anticipated workload, and they needed to, and they realized that the RAM that was provisioned for their service was not going to be sufficient. So they needed to bump up the RAM, and they were able to do that with a click of a button, rather than having to, even if in a best case scenario, in a on-prem infrastructure scenario, you need to find another, you either need to take out the server and pop in more RAM, or you need to find another server that is already provisioned and then create the, set up the operating system, all that, and then move your application from one server to another. Cloud offers redundancy by default. All cloud providers provide multiple regions, multiple availability zones, and if you architect your application to make use of that, you get built-in redundancy and built-in failover without a lot of effort. The most important thing is entrusting hard problems to the experts. Security is a very tough problem and a very challenging one that requires a lot of expertise. And relying on a partner, a cloud partner that has that expertise in security and in other areas, removes another thing that your organization needs to focus on. And allows you, again, going back to the theme of, allows you to focus on what gives you value, not something that everybody else, and not having to become a subject matter expert in everything. Serverless. It's even a newer concept than the cloud. Serverless is kind of a layer that sits on top of the cloud, whereas with the cloud, in general, the base unit is virtual servers. So Amazon EC2, for example, you're provisioning a VM, you deploy your code there, you set up your service, you get your OS. With serverless, it removes those layers of abstraction. There's no more server, there's no more OS that you have to think about. That doesn't mean there's no OS and no server there. Serverless doesn't mean no servers. But it's a platform, serverless is a platform for you to implement application logic and focus on the code, not the infrastructure. It's not just function as a service. One common misconception is that AWS Lambda, Azure Cloud Functions are what serverless is. Well, function as a service is just one type of serverless paradigm. Serverless is anything that allows you to focus on your code and to focus on delivering value without focusing on hardware and resources. We're running a little short on time, so I'm just going to kind of breeze through some of this a little bit. Application platform is what ties it all together. It connects the app front end with various back-end services. It supports agile and continuous workflows, and it includes productivity enhancers to automate important but repeatable tasks. An application platform lets you focus on the unique value of your app without worrying about complex, common problems. So a couple architectural patterns that are worth talking about. The first one is decoupled development. And when you're developing a modern app, it is important to try to separate out your concerns into different components so that you can have different members of your team focus on different areas without a dependency tree that makes it really difficult to get things done. Classic example is developing an app that has to connect to an Oracle database. And now I have to wait for my IT department to provision my Oracle server. And so a decoupled development model, separating out the front end from the back end, allows a developer to write the front end, work against some kind of mock data, while the back end developer is working on the integration with the Oracle database, and at the end, the two of them have a middle layer that helps join the two without much effort. Layers of abstraction provides, the idea behind this is to provide an interface for a front-end developer to access many different sources of data or different APIs with a single interface type. So again, the middleware layer acts as a facade for different back-end functionality, so a front-end developer does not have to become an expert in all the different types of back-end systems that are out there. Functions as a service. We talked about that a minute ago. Lambda is an example of that. Kinvey, Flex is an example of that. There are single stateless atomic functions at scale. You write the smallest unit of code possible. You invoke that from your client app. The key benefit of function as a service is that each function can scale independently based on its unique needs. So a hashing function that may utilize a lot of CPU that is used for authenticating users will have a different profile and a different scaling profile than something that is making an external call and is spending most of its time idle waiting for I/O to complete. Microservices. These are small, lightweight, single-purpose services that are used, that are divided up and used as part of your application. The emphasis here is on micro. When you're designing microservices, you want to mainly make sure that each microservice that is part of your application deals with a unique subset of functionality and really does belong together. One common anti-pattern I've seen is that you have a microservice and then you have something else that doesn't really belong there, but because you already have this service, you want to just bolt it on, and that ends up leading to a lot of kind of tech debt down the road, because as you're continually adding and you're maintaining, once you start to blend different concerns into a single microservice, and it ends up getting messy and making it more difficult to maintain. So even if it's just a couple of functions or a small amount of code, there's nothing wrong with having a microservice that just does one or two things. Cloud services are another architectural pattern to use in modern apps. And these are really no-code services that implement some back-end application need. Cloud data store, file store, user management, integrations with other external data sources. These are all, cloud services, microservices, functions as a service. These are all tools in your toolkit. Again, to allow you to focus on the value of your app without thinking about all the details that are really solve problems and don't really add value to your app. And so just a quick discussion of the Convey platform and really what it, and how we utilize some of these services. So the Convey platform is, we chose JavaScript. It's written primarily in Node.js. You can, as a developer, you can build serverless functions and microservices in Node.js and use native script as a front end for your front end development. We also support other languages via SDKs for specific use cases, such as Java, .NET, and Swift. And we're committed to open source. Utilize many prominent open source components. Our SDKs are all open source and available for anyone to look at the source code, make improvements or make suggestions. And we also utilize a open source cross-platform development tool in NativeScript that has a very robust community behind it. The idea of NativeScript, write once, deploy to iOS, Android, and web. And Convey Studio, which is a UX tool. We talked about that productivity enhancer. It uses NativeScript and Angular to build the UX for those three platforms. And finally, there are a bunch of other productivity enhancers as part of the Convey platform. Rapid Data, which allows you to connect to any data source. Mobile Identity Connect, which allows you to authenticate against any backend authentication system. And Flex, which allows you to write functions and microservices that you can deploy and utilize from your application. And that's about it. Again, the whole mission from the very beginning behind the Convey platform has been to try to take away as much of the heavy lifting on common tasks as possible so that you can focus on the value that you want to build for your customers as you're building your application. And I just wanted to point out another talk that is this afternoon that you might want to attend that TJ Vental is going to be running. He's standing in the back there. One project, one language, 3 apps, which will be about building and sharing code between iOS, Android, and web. Is that right? All right. Thank you very much. I appreciate you coming. And if anyone has any questions before we go, I think we're out of time. So if you want to come on up and ask me, that'd be great. Thanks.